Guy dresses up like a bat clearly has issues.
It's the costume that transformed Bruce Wayne, would-be crime fighter, into an icon of heroism, justice, and strength. The Batsuit. The Batsuit has been a key part of its owner's mystique from the very beginning, but it wasn't always a source of protection.
It starts as a symbol, a creature of the night, something to terrify. It's designed to make you A, anonymous, B, more than human all at the same time.
Originally, Batman's suit was made of cloth. It could be easily torn and didn't include any special technology.
The first evolution of the Batman suit takes place in the late 1950s. The editors felt that strange, weird new looks were part of how to sell the story. You would do stories like Undersea Batman, where there would be a special Batman costume just for going underwater. And that began the introduction of the suit as technology.
Given the weaponry that he's facing and the situations he's created, you have to believe he needs more in his arsenal in order to combat the greater threat that he keeps on facing.
The whole idea of it becoming essentially a suit of armor evolved over the years.
The inspiration for some of the technology of the Batsuit was almost accidental. When DC artists added a yellow circle to the suit, one that looked like a bullseye, writers were inspired to add a new aspect to the outfit.
When they started addressing the question of it being a bullseye, they took that opportunity to go, well, yeah, okay, then it is a bullseye. He wears Kevlar behind that section of the costume, hoping that criminals will actually fire at that, and it's bulletproof. Well, once you start doing that, the next logical question is, well, if you're going to wear Kevlar there, why aren't you wearing Kevlar under the entire costume?
Kevlar bi-weave, reinforced joints.
Tear-resistant.
This sucker will stop a knife.
Bulletproof.
Anything but a straight shot.
Kevlar's cool. It's 5 times stronger than steel, and when woven in layers, like 3 to 7 layers, it will protect the body.
Developed by DuPont in 1965, Kevlar material gets its life-saving properties from the unique way its synthetic fibers are woven.
In Kevlar, you have a bunch of fibers that are interweaved with each other, and so as they get hit, they actually stretch. The individual threads are fighting against each other, and it can resist very large impacts and high-speed bullets without actually breaking. So if you have a suit made of Kevlar, and you want to know how close you can be to someone who's shooting at you, interesting question is less the range than the actual size of the bullet and the speed. And Kevlar vests can cover a wide range, and most, hand pistols and even some shotguns, Batman would be very safe against, even up at close range.
In The Dark Knight, Batman's Kevlar suit gets an upgrade to the next level in defensive gear.
I'd been looking for the story reasons for redesigning the suit, and then it occurred to me it's actually very simple. We just would have it be the real reason we did redesign it, which is he wants to be able to move faster and more flexibly. That's what we put into the story.
Hardened Kevlar plates over titanium-dipped tri-weave fibers for flexibility. It'll be lighter, faster, more agile. Perhaps you should read the instructions first.
We collected together, read about and looked at all these sort of Under Armour suits, what the Army use. So we just set about redesigning the suit. We see that it's made up of much more facets, like a suit of armor.
The separate plates of armor of the new Batsuit are anchored on an elastic mesh.
It's 110 components to this suit. We decided that smaller armored plates would allow a crumple zone between those armored plates and allow him more movement.
The Batsuit's flexible, armor-plated design parallels an actual technology called ceramic armor, made by companies like Ceradyne Incorporated in Costa Mesa, California. Their ceramic plating has the resistance of steel, the material that's long been used to stop bullets. But ceramic plating is 70% lighter.
To stop the bullet, you have to break the bullet. Therefore, you need something that is harder than the bullet. The lightest weight, hardest material known to man for these types of applications is known as boron carbide.
Boron carbide is a black crystalline powder. When heated to extreme temperatures and formed into ceramic plating, it becomes nearly as hard as diamonds.
So where you are right now are in the hot pressing area
This is where we take a powder and we make it into the lightest, hardest material known to man.
Transforming the particles into armor begins by pouring the powder into forms and then compressing the material. The armor molds are then put into a hot press.
And behind me, you can see the hot presses. These are induction heated, and they operate at temperatures close to 4,000 degrees Fahrenheit.
The plates are then cooled, but they're not safe to be used as armor yet.
On certain high impacts, ceramic armor plating still will shatter. But that's actually a benefit because it really dissipates the energy into the shattering of the material instead of your body.
But shards of shattered ceramic plating can still be deadly if they enter the body. To prevent this lethal possibility, a special resin is fused to the back of each piece of armor to catch the broken shards.
The final step is we have to put out an outer layer. The outer layer is called the spall shield. So when a bullet comes in, not only do you stop it and catch the fragments in the back, but there may be a little bit that tends to fly in the wrong directions. This will stop it.
Armored protection, like Batman has in his suit, is essential to military personnel around the world. As shown in this video, taken by an enemy sniper, ceramic plating can be a soldier's best defense when under attack. The shot was aimed at the soldier's heart, but he survived thanks to his body armor.
Development of the Ceradyne armor has resulted in thousands of lives being saved. You can hold the muzzle up against a guy's chest and pull the trigger, and we'll stop that bullet.
For my opinion, you need to lighten up. Batman can not only take a bullet, he can also literally take the heat. Thanks to the fact that his suit is made of the real fireproof material known as Nomex.
Nomex is used in firefighters' uniforms. Welders can wear it. Racing car drivers can wear it. Anyone who's at chance of being near a high flame situation or an explosion.
When exposed to flame, regular cotton fabric ignites instantly. But clothing made of Nomex doesn't burn.
It doesn't catch on fire, it doesn't melt, and it doesn't do any of the horrible things you think of when you're in fire, so that you can withstand fires for minutes without melting, burning, or igniting.
Nomex is a fiber with built-in flame resistance. When exposed to intense heat, the fibers carbonize and become thicker, creating a protective barrier between the suit and a person's skin.
Batman can basically walk through flames with this material, and the only thing he'll feel really is the heat. And if Batman rolls and falls and gets the fire out within a few minutes, he's certainly going to be fine.
One of the essential parts of any superhero's suit is his cape, and Batman is no exception. But his cape benefits from a blend of real-life tech and the type only found in the labs of Wayne Enterprises.
Do you have any lightweight fabrics?
You know, I think I have just the thing. It's called memory cloth. Notice anything? Molecules realign, become rigid.
What kind of shapes can you make?
Can be tailored to fit in any structure based on a rigid skeleton.
On first glance, the fantastic fabric seems like, well, a fabrication. But surprisingly, scientists say material with memory is in the works, and someday, items like Batman's amazing cape may become solid objects with the help of magnetism.
One that's been under active development is something called magnetorheological fluids. You have a fluid with little particles in it that when you apply magnetic fields, they all line up and they become very, very stiff. The problem is the amount they move is very small. So you would need a lot of them to have any sort of effect on your cloth. But it is not something that's technologically impossible. It's just something we haven't figured out how to do completely yet.
Okay, so let's say Batman's cape can harden into a wing. That doesn't mean he can automatically conquer the challenges of flight. Even real bats have difficulty accomplishing the feat.
Bats are not very effective flyers. They're excellent gliders. The energetics involved in bat flight is really quite high. They're not particularly graceful.
But Batman's method of flight doesn't involve the flapping motions used by real bats.
If you look at the Batman films closely, you will find that he starts from a high location and gets to a low altitude through the use of his cape. And in this regard, the cape really is not a flight mechanism, but more of a gliding mechanism.
If you have figured out how to make the memory fabric in this cape, it can give you the necessary lift to at least glide and float for some distance. The challenges you have to figure out are how to get enough lift to travel the distance he wants to do. It's the speed that he moves forward with that's key. So he might do it by falling enough distance and let gravity speed him up. And for that, he'd need to come from a high enough building.
Believe it or not, people can actually glide like the Caped Crusader. In our world, we may not have Batman's transforming cape, but we do have something similar: wingsuits.
The way this thing works is there's a slit right here. Air goes in the arms and fills up the suit. Actually, this whole entire suit is one big wing. The whole entire thing fills up with air, and that's kind of what helps you fly. You're not just controlled falling anymore.
So a wingsuit works basically the same way that we expect Batman's cape to work. You have the fabric shaped between your arms and your body and your legs in a way that gives you an airfoil type effect, a wing-like effect that generates lift as you move forward through the air. But if you look at the way they use wingsuits, you can tell that there's some dangers there in terms of the way Batman uses his cape, is most of the people using a wingsuit also have a parachute for the last bit to get them down to the ground safely.
Of course, not all of Batman's technological tricks are in his suit. For others, you have to look closer. Inside the most mysterious and versatile toolbox in superhero history, the utility belt.